The first one is called as the random access, also called as contention methods. In this method, the stations are transmitting the data in randomly. That means there is no sequential order. The data transmission cannot be done by one computer and the next computer and the next computer, means there is no a sequential order. Any station can transmit a data at any time. So it is called as random. Okay. Now in this random access, no station is superior to any other stations. A protocol will provide some procedures, and a station that wants to transmit some data, they have to follow that procedures provided by the protocol. Whenever the station want to send some data, they will take the decisions by using the procedure provided by the protocols. This decision is actually depend on the state of the medium. That means whether the medium is busy or just idle. Whenever the medium is idle, the data transmission occurs. In this technique, if two or more stations want to transmit the data at a time, in that case, they are competing with each other for the media. Means which station has to transmit first. For that one, they have to do some competition. For that purpose, it is also called as contention method access here. If more than one stations try to send some data over this common network, there is a possibility of conflict or collision of the data occurs, due to which the frames or the data may be destroyed or modified. To avoid such conflicts, station has to follow some of the procedures which is provided by the protocols. Some of the random access protocols are pure aloha, slotted aloha, CSMA, CSMA-CD and CSMA-CA. Today most of the networks are using a protocol called as CSMA-CD or CSMA-CA. The first random access protocol we are studying is actually called as carrier sense multiple access, which is also called as CSMA. In CSMA, the stations are first check for the state of the medium before sending any data frame. So it's also called as sense before transmit. These are actually based on the principle of sense before transmit. If any station want to send some data, first it will check for the medium, whether the medium is in busy state or idle state. If the mediums are in idle state, then it will transmit the data over that medium. This will reduce the possibility of collision for some extent. There is a possibility of collision because due to the propagation delay of the data transfer. When a station sends a frame, the first bit of frame should be reached to every station, but it will take some time to reach to the every station. In that case, another station tries to identify or sense whether medium is idle or not. Since the first bit is not reached to the every station, the second station thinks that medium is idle and it will transmit the data. Both stations transmit the data over the same common line. There is a possibility of collision. This collision occurs due to some propagation delay in the medium. Now I will explain with some example here. Now this A, B, C, D are actually the stations or the computers which is connected in the network, and these computer wants to transmit some data frame over a network, and this vertical line indicates the time frame at what time these stations are transmitting the data. Now consider here the station B want to transmit some data over a medium. So first it will sense the medium at a time t1. At a time t1 it will sense the media. The media is idle. Nobody is using the media. It's idle. So it will send one frame over a network. After some time, that is at t2. Now see here, this is the time of this is the time called as t1. At this time, the B transmit the data. After some time, at a t2, C want to send some data. So at a time t2, it will sense the medium. But the frame sent by the B takes some time to reach to the C here. Now see, the first bit of the frame is still here. It never reaches here. So C senses that the medium is idle here. It says that the medium is idle. Okay. So the C send one frame over a media. C send one frame over a media. This is the line for frame sent by the B, and this is the line for frame sent by the C. Whenever it reaches at a particular point here, both will be collide, and the data will be lost or damaged. So there is a possibility. Okay, what is the time duration here? Okay, this is the time duration between T1 and T2. Vulnerable time. The vulnerable time for CSMA is the propagation time, that is TP. This is the time needed for a signal to propagate from one end of the medium to the other end of the medium. Now, for example here, if station A want to send some frame at a time t1, it is not reached at the another end called as D at a time t1. It takes some more time, that is called as t1 plus tp. It will take some more time called as t1 plus tp to reach at the another end called as D. This tp is called as the propagation time. Additional time to need for the reaching the data from A to D. This time is also called as vulnerable time. What are the techniques applied by the CSMA protocol to check for the or sense for the media, whether it's a idle or a busy? These are actually depending on three probability techniques. The first one is called as one persistent method, second one is non-persistent method, and third one is called as the p-persistent method. In the first persistent method, in this method, the station is continuously sensing. If the media is busy, means somebody is actually transmitting the data, it is continuously sensing the media. If it finds that the media is idle, it just transmit the data immediately. That is called as probability 1. In this case, it has the highest chance of collision here, because the reason is more than one stations are actually continuously sensing for the idle state, and more than one station can transmit the data at the same time here. Okay, that is the problem with one persistent method. The second persistent method is called as non-persistent method. In this method, if the line is idle, if the transmission line is idle, it sends data immediately. If the line is not idle, means busy, then the station will wait for some random amount of time and sends it again. If it is idle, then transmit the data. If still it is busy, again it wait for some random amount of time and check for the transmission medium again. This type of process is actually called as non-persistent approach. In this approach, it will reduce the number of reduce the chance of collision, but it is also less efficient because some of the time is wasted. Some duration will be wasted here. So this is the non-persistent technique. The next one is called as the P-persistent method. The P-persistent method is used if the channel has time slot with a slot duration equal to or greater than the maximum propagation time. Whenever the station finds that the line is idle, it will follow these 4 steps. In the first step, with the probability P, the station sends its frame. With the probability Q is equal to 1 minus P, the station waits for the beginning of the next time slot and checks the line again. If the line is idle, it goes to the step 1, means it again sends the frame at the probability P. If the line is busy, it acts as though a collision has occurred and uses a back-off procedure. These are the steps involved in the P-persistent technique.